So we're looking at example 2. It basically has a data table. Okay? And the data that we're looking at has 2 pieces of information, time and predicted temperature. And then we're asked for a quadratic model for this data, so that's how we know we would be running a quadratic regression. Anything that you put data in and you're getting a certain equation out is a regression, and then the type of regression is the kind of equation that you want. Okay? In this case, a quadratic, and then we're going to use that to predict some things. So first of all, this one told you guys quadratic model, but what if it didn't say that? How would you look at some data? When would you make a decision about whether you wanted to run a linear regression or a quadratic regression, or eventually we're going to learn lots and lots of different shapes of things that you could graph? What would make you decide to run one type of regression rather than another type? What do you guys think? If they didn't tell you. So think about our knot tying activity, right? Our knot tying activity, you guys ran a linear regression. What did that data look like when you actually drew the data points on the graph? So yeah, it almost looked like a straight line, right? So the shape of your data tended to follow the shape of a line. So we chose to run a linear regression, okay? If the shape of our data looked different, so look at this data, okay? Specifically look at the y values here. Okay. Notice it goes from 52 to 59, 63, then it kind of stays at 63, and then it goes back down to 58 and down to 56. So if we plotted this data, it wouldn't look like one line because it tends to go up and then it tends to go back down. Do you see why somebody might want to use a quadratic model, even if they didn't tell you? Okay, so eventually what you guys want to be able to do is look at the data, the numbers, and the scatter plot and make a decision about how your data should look. So here's what we're going to do. We're actually going to have you guys, since you are supposed to know how to use the calculator, use the calculator to find the quadratic model, which means get the equation. I want all of our equations to be the same, so I want us to use kind of the same data. I cannot just type the times in the way they are right here. Does anybody know why I cannot just type the time data in how it appears in this problem? Taylor? Good. The calculator can't account for AM and PM, so when you type those 8s and 11s, it's just going to plot points at the same place thinking those are the same time. All right, so we're actually going to use like a military time or a 24-hour clock, which means midnight is usually your like 0. So 8 a.m. is 8 hours after 0, 11 a.m. is 11 hours, but what would 2 p.m. be? 14, good. And then 5 p.m. is 17, and then 20, and then 23. So we're putting in these x's to go with those y's and understanding that when our calculator gives us an x answer, we have to interpret it the same way we did these here. So I'm actually going to give you guys some time to do this and walk around to help people. I'm not going to walk back through the calculator strokes in class. So your goal right now is, do I know how to put data into the calculator? Can I see the scatter plot on the graph? Can I get a quadratic equation that matches this scatter plot? And the quadratic equation, it says we're going to round to the nearest hundredth, okay? So I'm going to pause this one. Okay, for your equation, so your equation gave you an A value of like negative 0.16, right? If I round to the nearest hundredth. What was our B value? And then what was our C? Okay. So is everybody okay with getting a quadratic model? When you guys visually saw the plot, the stat plot, the scatter plot that you guys made, did you see why a quadratic in this case made more sense than trying to just run a line? You can run a linear regression. The calculator will do whatever you say. So that's why it's important that you start looking at data and being like, oh, this shape might be better, this shape might be better. And if you have to, you can even run multiple regressions and kind of look at them with your scatter plot and their R-squared value and see what they get. People that have your diagnostic turned on, and if you don't, we can do that. What did you guys get as the R-squared value as a note here? Yeah, she got 0.9. It was like 188. Is that right? Okay. So remember that this is kind of on a scale from 0 to 1. Here's how well this curve is fitting the data. This is the best quadratic curve for the data. Does a quadratic curve fit the data pretty well? Yeah. Okay, because it's like the 0.9s. Once you get down to like the 0.7s and stuff, I don't know. Okay, but this is pretty good. And then it says use your model to predict the high temperature. At what time does that temperature occur? What part of our parabola would we be looking for here? Good, the maximum, our vertex. And you guys could get that off of the calculator, or you could do the negative b over 2a calculation. Okay, either way, you should get a vertex that looks something like 16, comma, I don't know, mine gave me 62.76, but you might have something slightly different depending on if you had to insert your equation or you typed it in with the rounding that you did. So what does this mean if this is the point I get as the maximum value? What's the actual maximum temperature that my curve is predicting? Which one of these is the maximum temperature the curve is predicting? Morgan? Good. And so yours might have been slightly different, okay? So it's saying the highest temperature is going to be, this is what I'm getting, but some of you got like 43 point, that's fine, as long as I can look back and see what you entered in. And that's happening at 4 p.m. because that's what 16 meant in my x values. Now, some of you are not okay with that. Some people aren't okay with the fact that 62.76 is what I write because they can see a 63 in the chart, so they're like, wrong, that's not the maximum. Well, the data does not fit perfectly on a curve. We did the best we could to fit it on a curve, but it's not perfect. Once you've entered the data, you don't answer any questions using your data because that's just like one day of data, right? It's a one-time experience. So you don't gain everything you ever known off that one time. I don't go, oh, my sister is 5'10" and she wears a size 9. Every person that's 5'10" wears a size 9. No. What I would do is I would collect heights and shoe sizes of people and run one model through there. And I wouldn't use a piece of data to tell me. I would use my model because it's kind of averaging all of the data and looking at in general what happens. Does that make sense to people? So when you answer the questions, you don't answer them from the data, okay? That's like giving a one single example. You answer them from your equation because your equation is trying to find the best average of all of these things that are happening, okay? Is everybody okay with this? So the second part, like skill 5 homework, is kind of more on the calculator use modeling, like modeling with data. Skill 4 is more like the modeling problem that we did on Friday, like where they just give you an equation and you're looking for a certain part of it to answer their question. The last thing we're going to do here is we're going to make an equation if we were given 3 points. Now, if we were allowed to use a calculator, these 3 points could be like their own little data table, right? And we could put those in and we could find one parabola that exactly goes through the 3 points using the calculator. However, we can also find an equation for this without using the calculator. Okay? Now, do we have the vertex of the parabola in this example? Does anything up here specifically say it's the vertex? No. So I'm not going to start with vertex form, if that's okay with you guys. I'm actually going to start with standard form. So in my mind, I'm thinking like this. And I basically don't know very much information. Okay? However, when they tell me -2, -4 is a point, here's what they're telling me. When I plug -2 in for x, I am supposed to get -4 for y. Is that okay with everybody? If -2 goes in for x, y is equal to -4. And so what this does is this creates an equation for me that says -4 is actually equal to 4a minus 2b plus c. By itself, that's not very helpful because I can't solve that one equation to figure out a, b, or c. I could guess and check some different things and see if I could figure something out. But I have more information, right? I have another piece of information. I have one -1, which also means if I plug 1 in for x, I'm supposed to get -1 for y, which tells me -1 is equal to a plus b plus c. Again, by itself, not totally useful, but I could start connecting these equations together and solving systems of equations. Okay? But how many variables do I have in my equations here that I need to figure out? 3, A, B, and C, right? How many equations will I need in my system if I'm looking for 3 different variables? 3 equations, right? So this actually totally takes us back to our 3 equations, 3 unknowns situation. So we first just have to understand that a point means we know certain things plug in and produce certain numbers in an equation. We can build an equation from that. And now we're going to solve this like a system. Okay, so I'm going to actually combine the first 2 equations. It won't let me get it. There we go. Okay. All right, I'm going to combine these 2, but I'm going to multiply this one by -1. I'm going to aim to cancel out the C's. I think the C's look easiest because I don't need to like multiply by a number. Is that okay with everybody? Everything just has C at the end, so I'm going to work on that. So I'm going to keep this first equation the same and multiply the second one by -1 and combine them together to get -3 equals 3a minus 3b. That's not an answer, but I'm going to put a little box around it because I don't want to lose it. And I know these get messy. Then I'm going to take the second and third equations and combine them together. And I think, again, I'm just going to multiply the second one by -1. Okay? So I'm going to have 1 equals -a minus b minus c. And I'm going to combine that with 11 equals 9a plus 3b plus c. So I have 12 equals 8a plus 2b. Okay. And now I'm going to combine those 2 equations together. So if you guys remember, let's see, I'm going to multiply the first one by 2 and the second one by 3, focusing on canceling out the b's. So I would have -6 equals 6a minus 6b, and I would have 36 equals 24a plus 6b. So I get 30 equals 30a, and so a is equal to 1. Is that okay with everybody? And then I'm just going to work backwards like you guys have done before, plugging in these things to find b. So I'm going to plug a back into this equation. So 12 equals 8a plus 2b, but I'm going to replace a with 1. So that's just 8. So I'm going to get 4 equals 2b, which means b is equal to 2. And then I'm going to plug them into one of my original equations to find c. So I got that c equals -4. And my answer to this equation, remember what I was trying to do? I was trying to find an equation of a parabola. So my final answer here is that y equals a, which is 1, x squared, plus bx plus c. And if I wanted to check my answer, how could I check that my answer was correct in this problem? Anthony?
Plug in all like this.
Good. All of those points should work in here. If I plug in -2, I should get -4. If I plug in 1, I should get -1. If I plug in 3, I should get 11. Okay? So basically today's lesson was building equations in standard form, that we can do it in the calculator from data, but we can also do it by hand if we know that the points are actually on the parabola, if we have at least 3 points. If they didn't give us the 3 points, we'd need something more specific, like the vertex point or something more special about our parabola. Okay? Are there any questions that